Hello everyone, welcome back to the channel. Today we're going to implement the integration test for the main view model, and we're going to do our end-to-end test. Under Pocket Goods, I'm going to delete this file. I'm going to create a brand new test. Let's call it main view model test. As usual, we need the instance of the view model to test and the testable features, authentication feature, Pocket Goods, which is the main section, and settings feature and wishlist feature. Let's initialize the needed dependencies. Let's create the needed instances, memory database, mock crypto service, and cancellables set of any cancelable to be added under sync function. As usual, we have to override this setup function and to give the needed instances, memory database, and whatnot. I'm going to create a function or a private function that's going to set up the view model. Every time we're going to launch a test, it has to be annotated with main actor, set up view model. First of all, we need the instance of the API service. Let's provide here the session, mock URL protocol, and make session. Now we need the auth repository and settings repository and wishlist repository to construct basically the use cases dedicated for auth use cases, settings use cases, and wishlist use cases. And finally, we can have the view model, main view model, auth use cases, settings use cases, and wishlist use cases. We're gonna keep it simple. In this main view model, we're going to test only one function under the main view model, which is the main view model can stream application settings. Let's annotate this with main actor. As usual, let's check if we have an instance of a view model, otherwise we're going to fail the test. Let's call here, first of all, setup view model. Next, we're going to set or to arrange the expectation of the publisher app settings. And we're going to observe basically the states. Let's call this parameter state. Let's assert that the isDark theme is set to false because this value should be the default value of our theme. And here let's do store under cancellables. And we have to act by calling view model on event, on set, for example, on set current destination. And let's set the current destination to wishlist manager screen. And we have to specify here on which we're going to fulfill the expectation. We're going to fulfill the expectation when the latest visited screen equal wishlist manager screen. And we have to wait for the fulfillment of the array of expectations. This is a very simple test. Let's go ahead and run the test. The build fails. Let's check what we have missed here. Let's add all the features to the test target. All right, we have a problem actually in our dependency ingestion mechanism. Let's investigate. First of all, I'm going to make sure that we have provided the dependencies under install. I think it's correct. Let's check the app container. We are using here the singleton approach. And I can see here what's going on. Basically, this section is wrong. No wonder SwiftUI is not able to find the dependency. What we have to do here, we need to change it to lit. And it has to have only one instance of the container. The container is not sendable. All we have to do here is to remove pre-concurrency and remove the sendable and annotate this with main actor. This is going to lead us to refactor a little bit our code, but nothing crazy. Let's go back to the product feature under DI. We have to mark this function with main actor. Let's do the same thing for the other features, main actor, because if we don't do that, it's going to complain basically about the shared instance. It's not isolated. Therefore, we have to add here this function as a main actor to make it thread safe, settings feature as well, and the wishlist feature as well. Next, in the app dependencies, we have to mark this with main actor. Let's check the install under app test module. We have to add here main actor. In the Pocket Goods inject, we have to add here main actor. I think that's pretty much it. Let's try again and run the test. At least we don't have any errors. And the test succeeded. Finally. All right, that's pretty much it for this particular test. Now we are ready to define our robot and preparing the end-to-end test. I'm going to proceed basically with the same manner under Jetpack Compose. We're going to do pretty much the same thing here. Now we're going to work on this particular folder. I'm going to delete those files. We are not interested in this. I'm going to create 3 folders. The first folder for end-to-end test, the second one for helper, and the third one for the robot. Let's focus on the helper section by defining the reusable class end-to-end test. We have done basically the same thing under Jetpack Compose. Let's try to do the same thing here. Let's call it end-to-end test. We need to launch the application and set the environments. As usual, we have to override the function setup with error. In this particular function, we're going to launch the application and we're going to set the environment for our testing. And let's override this function tear down with error. I'm going to make it reusable by defining 2 functions that we can override however we want. Function on setup and another function on tear down. In this particular text, after failure, I would like to stop the test by doing continue after failure equal false. And let's add here the instance of the application that we're going to use. We can get the instance of the application by calling XCUI application. And before launching the application, I would like to set the test environments. More specifically, the test environment that we have done under is in test, wrapped values. We have to set this particular one. All right. To provide this argument, we can do application and launch arguments. And we have to append is in test environment, and we can access the test process argument. As simple as this. Next, we're going to call the function on setup, whatever we want to do before launching the application. Then we're going to call app and launch. After launching the application, I would like to force the portrait mode for this, or the orientation of this device by using, let's call here device, XU device and shared. And we can do device orientation equal UI device orientation and portrait. For the implementation of tear down with error, let's call the function on tear down, and we have to terminate the application. Now our usable end-to-end test is ready. Next, we have to implement the robot to make it reusable. The dependency of this robot is the application of type XCUI application. Let's add here the public getter, and let's add here the public initializer. Now we have to basically implement the same functions that we have done under Jetpack Compose. Let's start with the first one. To scroll and assert that an element exists. Get the scrollable element. We can get this by accessing the app scroll views, and we have to access here the scroll views identifier. Let's call it scrollable identifier. Now, if you are not able to identify this as a scrollable element, it has to be under other elements. If it does not exist, let's check under other elements. Maybe it's going to be present by doing app, and instead of scroll views, it has to be of type other elements and assign here scrollable identifier. If this scroll element exists from either scroll views or other elements, otherwise, let's fail the test. Underneath, we have to do an early return. Next, we have to get the target element using specified trait. I'm gonna add it here as a function. We can do this in Swift. This function should give us XCUI element, and we have to switch over the accessibility trait. Let's hoist this accessibility trait and assert exist. And let's make it by default as static text, because remember we are trying to scroll to any element. Here we have to do accessibility trait. And of course, we're going to check first of all if it is a static text. We're going to return scrollable element and static text. So it's going to get any static text under this scrollable element, and we have to do here the target identifier. Let's add the target identifier as a parameter. It has to be a compulsory parameter, target identifier. Let's say, for example, we are looking for a button inside the scrollable element. We're going to do here is a button and target identifier. If it doesn't fall any of those categories, let's make it simple and use default and do return scrollable element and other elements. If it does not exist, it's not going to be shown anyway. It's going to give us an error. we need to make sure that this particular element is visible. I'm gonna use it as a reusable function within this particular function, is target visible. Let's store the element that we have just obtained from the previous function. If this element exists, and if this element is hittable, basically determines that this element is accessible, you have to return true. Next, we're going to return this element and to check if it is partially visible by doing return scrollable element and frame intersects, and basically here elements and frame. Otherwise, it's not visible. Next, we're going to loop until the target is visible or timeout occurs by doing while. Let's add the timeout here under the function parameter. Before this, we have to set the start time equal date, time interval since the start time less than the scroll timeout. All right. Next, we have to check if its target is visible. If the target is visible, we're gonna make here an array return. Next, we need to calculate the Y offset. Next, we have to detect if the scroll is in progress by doing visible elements from the scroll elements and descendants. It's gonna have, for the matching, it's gonna be any UI element, all elements bound by index to determine that those elements are bounded by the index. And we have to filter the scrollable element that is within the frame, and frame intersects first parameter and frame. Basically, it is partially visible. Now we have the array of visible elements. Let's store the current offset from the first element equal visible elements, the first one, and let's get its Y position by doing origin and Y position. Otherwise, it has to be 0 or the first of the offset. Now we have to stop if no more progress. Basically, we are reaching the bottom, previous offset. Let's store the value of the previous offset. It is the previous offset because it's null. If it's not null, and we have to take the previous offset from the current offset, this value should be less than 1. Otherwise, we have to leave the loop. We have to store the previous offset from the current offset. Next, we have to specify the sweep direction. I'm gonna create an enum for this. Let's set, for example, up, down, right, and left. I'm going to hoist this particular sweep direction to make it reusable under the scroll to element. By default, let's assign to up. Basically, it's gonna scroll down. Let's add here the sweep direction. Let's add all the other cases. In this particular case, we're going to do scrollable element and sweep up. Here it has to be sweep down, sweep left, and sweep right. Next, we have to wait for a while, basically the duration in between sweeps. Let's call here sweep delay, an interval, or add time interval, and we have to pass here the sweep delay. Now it's time to make the final assertion to make sure that you have the final element after scrolling. Let final element equal target element, and we have to make the assertion that the final element exists and the scrollable element is visible by doing frame and intersects final element and frame. I think that's the most complicated function that we have to implement under the robot pattern. Because we are going to deal with images, we have to make sure that the image is visible. Let's add here the identifier. We can access the image by doing image equal application. And there is a query for this images identifier. I'm going to assert that this image is found. With the same manner, we have to assert that has a button. Instead of using images, we're going to use buttons, and we have to make the assertion. In some occasions, we would like to wait and assert that a certain element exists. Let's do it for the image, and let's call it wait and assert image does not exist. As we have done in Jetpack Compose, let's provide here the identifier as well as the timeout. We can access the image by doing app and images, and to wait for the image to exist, let's store this information under exists equal image and wait for existence. In this case, we are going to wait for non-existence. Let's provide here the timeout. Afterward, we have to make the assertion. We have to assert that this value is true by saying, for example, image with accessibility identifier still exists. In our application, we need to access the text. Going to assert a static text element exists and matches the text. Let's get the text element, application, static text, and let's pass here the identifier. Next, we need to make sure that the element exists and the text has the same value from the value that we have done here by doing xct assert equal text element and label equal to the text that we have provided. If there is any error, we're going to show a message here. If you do remember, under the robot that we have implemented under Jetpack Compose, we have implemented a function on node. We're going to do the same thing here. Let's call it on UI element, and it should give us basically XCUI elements. We need the identifier, and the identifier is basically the accessibility identifier that we have assigned numerous times under our UI, and the accessibility trace, if it is a button or an image or whatever. I'm going to initialize first of all this element that we have to return to the function. In case of is static text, the element is application and static texts, and we have to pass here the identifier. The same thing for image and button and toggle button. If it's not under those categories, we have to do here the default value, which is application, first of all element, and application and other elements. And let's return here elements. In our application, we need to return the scrollable element and assert that the scrollable element or container exists. Let's call it onScrollable. I'm going to get the scrollable element. I would like to make sure that this element exists by calling wait for existence. I think I'm going to call this await onScroll element. First of all, let's get the scrollable container, and we have to assert that the scrollable container exists. At the end, we have to return the scrollable container. Let's add the timeout here of type time interval. Let's add here 5 seconds. We have to provide here the identifier for this button. Let's get the button and assert exists as we have done here. Let's do the other section, which is let's wait and assert a certain text does not exist, and to wait for the existence of the text. With the same manner, we have to get a static text and let's assert and waits for non-existent. Let's do the other one to wait for the existence of this particular text. All right, one important thing that we have to do here is to insert a text in the text field. Let's call it insert text. We need basically the identifier, the text, and the type of the text field, because here we have to distinguish between two texts or two types of text field, the normal one and the password. I'm going to create an enum that's going to represent the text field. Let's say here normal and password. Let's define the needed parameters. Let's store the results of the text field in case we are looking for a normal text field by doing application and text fields, provide here the identifier and first match. And for the other case, we have to do application and secure identifier and first match. First of all, we have to assert that this text field exists, and we have to perform tap on this particular text field. Then we have to fill the text by doing text field and type text and text as an argument. If you do remember, under the login form or register form, the user can click on the return button on the virtual keyboard. Let's add this function here and let's call it on keyboard return. First of all, we have to look for this particular button, equal app, keyboards, and buttons. It's returned. It should be capitalized. Now we have just to make sure that this button exists and is hittable. In other words, we can interact with this button. In this particular case, we have to do keyboard return button and tap, basically to click on this button. Otherwise, sometimes it won't interact with this button. Therefore, I have just to do here as a fallback to simulate pressing return key by typing this text anywhere if it fails to hit or to find the keyboard return button. One last function actually to implement here is to access the progress indicator. What we have to provide here is the identifier, and it should return UI element. Let's look for this indicator by doing application and progress indicators. Identifier and first match. Let's assert that this particular indicator exists. If it does not exist, we're going to do here a fallback message, and we have to return this indicator. I think that's pretty much it for the robust pattern. But before I forget, actually in the accessibility trait, we don't have the generic one. Under this, we can access as text or as button, but we don't have, for example, the generic one that should be assigned under other elements. Therefore, I'm going to create here an extension on accessibility trait, a static variable. Let's name it none of type accessibility traits, and it should return just an empty accessibility trait. When we're going to assign none to the function of robot, it's going to give us accessibility trait, which is empty, therefore going to use the other elements. I don't think that we will need anything else. I think that we're going to stop the video here. For the next tutorial, we're going to implement our first end-to-end test for the product and the main screen of our application. I hope you have learned something new, and see you in the next one. Happy coding!